Welcome to the stream. And basically what I'm going to show is how to build a Flutter app, but basically implement all the logic of the application logic in Rust. And obviously this all is based on foreign function interface call, so you can basically call from Dart to Rust via the FFI interface. But I created a tool that makes it a lot easier, where basically you write something like here on the left, and you basically just annotate your Rust code with something here. And then what happens is it actually allows you to then call functions over here. Hey Huyan, welcome to the stream. I hope you enjoy it. I remember you like Rust. I don't know how much you like Flutter. So this is the thing I've been working on for about 2-3 months now on my weekends and nights, trying to make it easier to combine the two. The motivation behind this is that Flutter is really awesome to build UIs, but Rust is, for me, I like that language more. It's safer, it's in a lot of cases faster. So yeah, then stick around here and you might learn a little bit of Flutter. We'll actually start with Dart. But basically, I try to basically make myself really happy, and everyone else who is like me, who likes to build UIs in Flutter with a really fast feedback loop and have them run in all devices. But at the same time, I want to write my logic in Rust. That's the main motivation there. So this is what we're going to do. We're going to build, and I can demonstrate this on either. I'm actually going to demonstrate this on. Let me move this here. We can see the phone. It's connected to my computer, so I can't move it further. But you can see that I can interact with it. Here, if you look at here on this one here, so I can interact with it. I can select filter, show me only the ones that are filtered or completed. Here, show me all the ones that haven't been completed. I can also say restart all of them, and I can remove one, and so on, right? And that all works and I turned this one off. So let me actually let me turn that back on. I'm trying to see if people will join if they see a lot of pictures. I think that happens sometimes on Twitch. So here we can see that it's the same kind of thing. It's basically one app like we're used to in Flutter. We can also add one. So I don't know, start the stream actually, right? We kind of start the stream, but you probably want to see how it's done. So here we can do that. We're going to start the stream now. This all works. Again, this is Android running, this is Mac OS running, and this is iPhone running. And so I'm just going to go through how to use RID. I'll explain a little bit about RID as we go. So the first thing that I'll do, I'll implement this with just Dart. And the reason for that is because that way we can easily understand how everything fits together. Once we actually move on to a Flutter project, it's a little more hidden how kind of RID is kind of integrated and how the Rust FFI and all these things are integrated. So so I figured that in order for everyone to understand a little bit easier how this actually works under the hood and kind of what's going on, we'll start with just Dart, and then we can actually use that Rust code that we developed for the Dart app. We can actually use that for our Flutter app as well. So let me close actually this now, and then close this. And we close the simulator and turn on my phone over here. And what I'll do is I'll move everything over to one desktop now. All right, and the chat as well. So I have that, so I can see questions. So let me just see if that works. Perfect. Okay, so this is what we're building, but we're going to start out with just Dart. Okay, everything else closed, only the Mac one is still running. That's fine. So let's start. How do we go about this? So first of all, we're going to actually create this as a Rust project. So we're going to say Rust new lib, and we're going to say Dart to do. Okay, so that created a new app, and whoever has been doing Rust knows what's going on. So we have a lib now where it's just some tests. It's not doing anything yet. So now let's actually set up. Actually, I'm going to go into Vim, and now let's actually set up a the Dart version as well. So we want to kind of drive this from Dart, right? So basically some of the, or most of the logic actually will be implemented in Rust, but the main application running is actually from Dart, right? So what I'm going to do is I'm going to just create a main method. Let's be nice and do it this way. And I'm just going to say print hello world for now, okay? Nothing too fancy. And now what we can do, we can go ahead and run this, right? So we can just say Dart lib main, boom, we just print hello world, right? So that's all great. But there's no applet yet, but definitely we're not integrating Rust yet at all. So what we'll have to do is we have to add something in here. All right, and so I actually did this before in preparation for this. So I'm going to actually jump over somewhere where you can't see, just to make our lives a little easier so I don't have to type everything by hand. So what we first have to do is we have to say that the crate type is this kind of a dynamic lib, C dynamic library, and that is necessary in order to be able to use this from Dart, right? And that is pretty much, I think, all I wanted to do for now here. Okay, so so now we could already build this. So we can say cargo build, right? And it would build this, but except nothing would be happening in this. There's really nothing going on here, right? It just tests. So, but since we're building a to-do app, let's actually just start and build the struct to-do, right? And so the to-do will have an ID. It will have a title, which is string, and it will have a completed flag, which is a bool. All right, so now we got that. So now let's cargo build this. There's nothing happening to special yet, and it's actually telling us that to-do is not even used, okay? Because there's no code yet that we're generating to use this from Dart. So, right, so we need to go ahead and do that. But first, we need to actually go through our cargo toml again. And we need to add some things. We basically need to first add the rid as a dependency. Okay, so that's the library that I created. Now, rid will be open sourced. Basically, we can ask, anyone who has questions about that can ask, but I don't want to go into too much detail, but I release it as sponsorware, meaning that I want to get a certain amount of sponsors to help me build this and maintain it before I release it fully. So for now, I have it installed locally here, and we can, so this is the rid, this is the main kind of library that gives us the macros that generate the code that we need to integrate with Dart. And then we have another one, built one, which we'll use in a second. So if I save this now, things should be happening because cargo will now go, oh, there's a new dependency, I need to do stuff. And that's what's happening right now. So what we also need to do is we need to add a build. But actually, what we can do that in a second. Let's first go back here, and now we can already annotate this, and we can say this is a model, and it's going to be a rid model. And now you're going to see that this actually now went away. Like it's no longer thinking that to-do is no longer used, but we are using a private type to do in a public interface, and you're wondering what interface? Well, that's because under the hood, rid created a bunch of accessor methods for us, which require our to-do to be public because we want to basically use it on the Dart end. So now we can go ahead and actually add the build script because we need to. That's the one part we're still missing. And basically, right now, how this works is you provide a script, which you'll look at in a second, and this will work differently in the future. In the future, I'm planning to have like kind of a rid command line tool which does all that for you. But for now, we'll live with this as it is right now. So I'm actually going to copy this over because it's quite a long script. Not that long actually, but too much to type here. So, all right. So we call it rid build, and it should actually not complain because it is included in the module trail, right? I include it here. So I'm not sure why it is still complaining. Okay, it'll go away in a second, I'm sure. But let's just look at what this does. It basically tries to derive the crate name, right? This is a crate name here. And from that, it derives what the lib will be called. And it needs to know that in order to know, because it will basically generate not only bindings, but it will also have to copy the Rust binary somewhere to be accessible. And then basically you give it a build config saying what our build target. We are creating a Dart project right now, and not a Flutter one. We'll create that in about an hour. Then we have to tell it a bunch more information, basically, so it can properly place all these things where they belong, right? So now, and I'm just going to show like how this works. If you look at the debug folder here, we got this lib dart to do. It's kind of hard to see. Let me actually make this one just a little bigger. It's going to be this dlib and things like that, which are created. And we basically need to then copy them, or at least we basically tell Dart where to load them from. So that's where we are right now. Now, what we can do now, we can invoke this build script. And I made this a little easier. So actually, let me push step by step. We'll get there. I know there's a few steps, but it's good to go through this one time. And for the Flutter one, we'll actually use a template because it's even it's a little more complicated. So let me open this and I put the build here and explain a little bit. So here we can say that we are running this build script here, right? This is that script. So we're saying run that from the root directory. And then we're doing this as Up Ffi Gen. And that's the part that we're still missing. So I'm going to implement that right now. So first of all, let me make this executable. And now we're going to go and create a Pop Spec, right? So, and again, we won't do this all from scratch. So I'll copy some of this over, but piece by piece now I will explain as I go. So we're going to do Pop Spec.yaml, all right? Okay, so name is Dart To Do. We have this environment, and now we're going to get in the next. We're going to have to add some. Actually, we're going to do this from the command line. We say pub add ffi. Let me actually save this first. And then we go ffi gen. These are the tool dependencies on the Dart end that we will need. Now, if I do this, now we have the dependencies here. Now, one thing I want you to know is if I run Dart lib main Dart now, it will complain that well, I expected a package, but you're running me directly, and we'll fix it in a second. So, but that's something you would probably see. So now we're gonna have to set up Ffi Gen. So what Ffi Gen is a tool, and by the way, if you're interested in what we're building, let me actually go here. I have some commands set up, and one of them is project. So this is what we're building. And it's also here. So first we built this version, and then we built this version. Now what I wanted to show is Ffi Gen. So these are these tools that the Dart team actually provided to help basically call C-like functions from Dart, and to help to generate that boilerplate code. And that's kind of what RID uses under the hood. So we got all this set up now, and the build should now be executable. Okay, and so actually at this point we should be fine to run the build. So now we can see that it's actually compiling. It's compiling not only our app, but it's also compiling RID because we were referencing it locally. And in a second, we should be seeing something interesting. All right, so let me actually make this a little bigger so we can see this better. All right, so one thing we see is that it's complaining that to do is a opaque struct, and that is on purpose, and I will go into more details on that. Basically, we are not sending the struct as is, we are sending a pointer to the struct. And I'll explain more in detail in a second about this. But basically, we can see that every property, let me actually open this up over here. Every property of the to-do now got an accessor method. So we can get the ID, we can get the title, and since it's a string, we can also just get the lang. And we have to free the string, which basically RID does for us under the hood, and then we can get the completed. And then we have some vec generated in case we are using vecs, which we are not using right now, but that's what that is. And so we can kind of see like the bindings that were generated. And now this is basically generated from cbindgen, which is basically this one, right? But cbindgen, as you can see, generated this from something called Dart Todo Expanded, and that's basically what rid does. It expands our code first with these attributes, and then Pfi Gen knows, basically finds these methods that it got generated, which are basically C-style methods, and we can actually see them if I just expand the macros. So if I expand the macros, we see, for instance, here how rid to-do completed its access. So it expects a pointer to the to-do, and then it does a bunch of stuff for us, and then basically then returns, and it converts it to an integer. That all generated by rid. You don't have to do that. Normally you would have to write all this code. Now Pfi Gen sees that part and then generates the binding for that. Then Up Ffi Gen comes along and says, okay, let me look at the binding, and then it generates these kind of things, right? And then rid comes along again and says, okay, well, let me put some extension methods on top of this. So this is actually a little nicer to use. Okay, so I hope that explains pretty much how rid works. If you have any questions, I have the, as you can see, I have the chat over here. I'm watching it. So if you have any questions, let me know. Maybe I'll make this chat a little smaller. All right, cool. Okay, so well, the last thing we need to do now is we need to be able to run it, right? And I showed that if we run it just directly with Dart, we get this weird error message. So all we're going to do, we're going to write ourselves a little script. And again, I'm going to just copy it here. And all it will contain is basically some weird thing where we're telling Dart this is a package and what the package is. We don't have to worry about this too much. This is just to get rid of this annoying error that we saw. All right, so now we can run it, and it doesn't do anything. Oh, that's interesting. Okay, so I hadn't saved it, and then basically the chmod was overwriting the file. Okay, so now it prints hello world like it did before. Okay, cool. But now we get to the fun part. So now basically, let's look at actually what we want to do, and I'm going to actually make a little plan here. I'm going to make a little plan of what we're trying to do. So what we want to do first, we need to get the model. So we need to init the model somehow. And then we want to, since in order to even see anything, we need to just add at least a to-do, right? And then we're just going to print the model. And that's what we're going to do for now. This is what our plan for right now. And basically all this stuff is going to be implemented in Rust. We're just going to basically interact with it from Dart, right? So close this one. Actually, what I'm going to do, I'm going to open these other files here for convenience. Let me see. I'm just going to make them small, but so we can get to them whenever we need to. I'm going to open the Pfi Gen binding and the regenerated. I'm going to open that here. Okay, cool. So we have access to those. Okay, now let's start with Init Model. How do we do this? Well, first of all, we don't have a model yet. Okay, so how do we do a model? Let me actually make sure I have that all in the order that I wanted to do it. Okay, so we don't have a model, but we can create one. So we want to create a model, and so basically your app can have multiple models. Like the to-do is actually a model, right? But there's going to be one main model that is basically holding your application state. And if you're familiar with something like Redux or React or things like that, that's basically the same idea. You have one application state. And obviously a model can reference other models, that main model, but you should only have one that actually is your application state and receives the messages as well. So what we're going to do, we're going to generate IDs for these to-dos just with ints. Obviously we could do better, but this works for now. Then we're going to have a vector of to-dos that we added, right? And then we're going to have a filter, but that's for later. So the filter we don't worry about yet. This is when we want to filter the to-dos, right? So now it's complaining that this field is never read. So obviously we had this before, so let's just add the model annotation here and say tell rid to generate these accessor methods. Okay, and now we got a problem. And rid basically tells us now, I'm missing the info for the to-do, and basically specify either that it's a struct or that it's an enum, and put it be one, whichever you have. And we have a rid model here, so put it below the model. And why is that? Well, the thing is that rid only knows about this piece of code. It doesn't know anything about this, at least like this rid model attribute, right? So the code is generated on top of each code that you basically annotate with an attribute. So in that, for that reason, it doesn't know what a to-do is. It knows that it's not a primitive type because here it doesn't have any issue. It knows that U32 is a built-in type, but for the to-do, we basically need to tell it that this is actually a struct. So we're going to say the structs in this model are, for instance, the to-do is one of them. Okay, now this error goes away. Now, if I change it, right, it comes back, but we can actually put multiples here, right, if you wanted to, but right now we only have one. Okay, so now we got the model, all right? But we still have no way of instantiating it from Dart. Like, how do we get it, right? So, but for now, just to go step by step, we're going to actually build this again because I want to kind of show you what happens now. So basically right now we see that we had all this to-do stuff, and now we got the model methods. And we can see that since we have a vector of to-dos here, we have a way to get to the length of the vector and to get items out of that vector. And now that's also very interesting because we don't actually pass that vector to Rust ever. What we're actually doing, since this model holds on to that data, we just provide Dart methods that allow us to index into this vector or get the length or whatever. So we never pass anything until you actually access it. And that way we also don't have to free this vector because the vector is held on also like on the model, like the model owns that vector. Okay, so now we have to implement something on the model so we can, and this is like typical what you would do in Rust, right? You create a new function, right, which returns self. And in this case, we're going to return a model which has the last added ID is 0, and then the to-dos, in this case, we just create an empty vec. And that's it, right? Now, let's run it to see what happens. Nothing. Like we still don't know how to access the model. Well, the thing is, we need to tell rid that we want to export something. So first of all, we need to say here, rid in this impl block, we are going to export things. So it knows to look there in the impl block, right? And so then we also, on each method that we do now want to export, we add another of these export attributes, right? So let's run it again. And now we can see that we got this rid export model new. So we'd actually have to call it like that from Dart. But that's not really cool. Like that's not really a nice method name. So we're going to say we actually want to call it Init Model. All right. So we can do that. And then if we run it again, we can see that now we actually have an Init Model function here, right? And by the way, don't worry about this one, that it's always empty. This is only used whenever we are building a Flutter project, just in case you were wondering. Okay, so now we can go back to our main Dart, and we can actually now init the model. Let's see if that works. Model, and we need to get the rid_ffi library in. So let's put that in, and then we're going to say init model, and we can see all these other rid methods that are also there. And we don't want to call those directly. Those are just exposed to be used with actually a nicer API will be on top of this. So we don't necessarily want to use them directly. But the init model we do. And now we're going to get a model. So let's actually print the model first before we do anything. So how can we print the model? Well, what we would do is normally you would say print, right? And then we'd say model. But the thing is, then we have to, well, this would print a pointer. As I said, the model is just a pointer. So we could obviously like implement a toString method in Dart, but why would we have to do that, right? We can just basically in Rust derive, right? Let me just write it like this. We can derive debug, and in this case, we also have to do that for the to-do. Okay. Is that enough? Well, let's see if something got generated. And nothing extra got generated here, right? So what we have to tell rid is, okay, it does implement debug, but I also want you to expose this to Dart, right? All right, let's run it now. And we can see now that we got two extra methods here, debug and debug pretty. And they basically correspond to the to debug, right? You can basically in Rust debug without the pound and with the pound, and with the pound is pretty, and without the pound is not pretty. So what we can do now is we can actually say model.debug, and we can see that this one actually takes a parameter which is pretty. So if you pass true, then it will print it pretty, and that's what we want at the moment. All right, so see, we build it, and then we can run it, and we can see now it printed it, and we didn't even have to implement the toString method because we're just using the one that's provided by Rust already. Pretty cool, right? So by the way, if you have any questions, comments, anything, if you think this is nice, or if something is especially surprisingly nice or bad, just comment so we can discuss it, and also so I can find out what people like and what people don't like. Okay, so we're printing the model, right? And we're actually doing really well on time. So that's why always time for questions if there are any. Okay, so now we need to basically mutate the model, right? We basically want to say add a to-do. And some of you might think, okay, let's just go ahead and say model, I don't know, model.todos, right, dot add, right? Or, I don't know, push, but there's nothing like that. There's the length, and we can get an iter, and we can also index into it. So all that is provided. Everything that's read-only, if you notice. So I can also iter, that's kind of like Rust. And so now I can use it in a for loop, and so on, right? But I cannot mutate it from Dart directly, and that is intentional. The way to mutate anything from Dart is to send a message to Rust, then run the application logic in Rust, and then mutate it as a result of that. So that's what we're going to implement now. So basically, we are going to implement a message for now. All right. So how do we do a message? Well, in Rust, we have enums that can take data, which is really useful in this case, because what we can do, we can say to-do, add to-do, and we can say the payload of that message will be the title of the to-do we want to add, right? So, okay, but that's still not enough, right? Because RID doesn't know that this is what the message is, and it doesn't know that it's for this model. It doesn't know anything about that. So we have to tell it. So we can say RID, this is a message. This is the message. Ideally, you would only have one message type in your application. Okay, RID is complaining now. It says, well, you want to tell me for which model the message is, like who's supposed to handle the message if it comes in, right? And as you can see, like all these macros, I wrote them in a way that if you make a mistake, it tries to help you, right? It tries to say, you know, I'm missing this or that, I'm not understanding that. So you don't just stand there and you're don't know what's going on. Okay, so we added the model, but now it's complaining here. It says no method named update found for mutable reference model. So what does that mean? Well, the thing is that, as I said, the message will mutate the model, right? So then we have to give it a way to do it. And RID basically expects an update method to exist on the model. That's kind of a convention, right? And what it will do, it will take the model mutable, right, self, and then it will take the message as input. And that's it. And it will basically just, it will not return anything. It will mutate the model in place, right? Now, if we do that, now this error goes away, and we just have a warning here that says, well, you're not using the message, okay? So that's no problem. We can actually use it. So first of all, to make the match arms nicer, that I'm going to do right now, we're using star message. And now we can basically say match on the message that we got, all right? And then we can fill in the match arms, and this will be the title, all right? And now we basically only have to create that to-do. We have to make sure we update our index as well, and then add it to the model. So let's go ahead and do that. It's really easy. So last ID, we add one, right? Then we create a to-do. ID self.last ID. And then we're also going to need the title, which is already given to us, and obviously completed is false, right? So that's our to-do. Actually, let me do it like this. And then all we have to do is self.todos, and we push it there. Okay. Everyone happy? That was pretty easy, right? And obviously, like, if this wasn't like a stream just to show how RID works, if you were building a real app, you would have tests down here, right? And while you're doing all this, while you're implementing the Rust logic, you could already run the tests and make sure that your logic works. And you wouldn't even run a Dart yet or Flutter in that case. But we are going to just do that now. So we're printing the model first, and now we're going to add a to-do. So, well, how do you get that message sent? Well, we know the message is for the model, and that's why RID will add something magically. So let's actually build that. And we can see that we now have a message, RID message add to do, which was created for us, right? But that would still be not so nice to use. So what RID actually does, it says, well, you probably want to send it to the model. So we're going to add an extension method here on that model, which you can just call, like send a message to the model, which makes sense, model send message, right? And then we're going to say my first to-do, right? And then in order to verify that this actually worked, we print it again. All right, so now we just need to run it. And there you go. First model had no to-dos, and then it did. All right, so let me verify what I wanted to do next. Right, so we got all that. We adding to do. So what we'll do is I'll actually copy some code from here to get us a little more to dos without writing it all out. So first to do, we called it ever. And so now what we want to do is, no pun intended, we want to now complete one, right? So at this point it should actually print 3 to dos, right? And it does, right? And you know, keep in mind, there's really no logic. All we're doing is we're delegating to Rust, right? Dart basically does nothing that has like a branch or an if statement or any. There's no logic here. It just says, well, the user wanted to add it to do, so I'm sending you the message. Go ahead and do that, and then it's all handled inside of Rust. Okay, and that's basically the beauty of it. So now what we want to do, we want to be able to toggle a to do, right? And I'm just verifying that this is what I wanted to. So actually we want to first complete it, and then we'll toggle it, right? So let's do that. What we only need to do is add another message, and one is going to be complete to do, and we're going to pass the ID of the to do that we want to complete, right? And the other one will just be toggle it. So if it's completed, it'll be restarted. If it's not completed, then it will be completed. So and so now let's go. Where is my cursor? All right, let's go here. It's complaining that we're missing match arms. So it's kind of nice, right? You add something to the message, and Rust actually helps you out. It's like, okay, look, you added some more messages. You're not handling them yet, right? So even before we can build, if we were now to try to build, it actually tells you, look, your app won't work, right? So you have some safety there, and that's another nice thing that Rust gives you. So now we basically have these two things, and they're going to be fairly similar in one case, because what they're going to have to do is going to have to find the to-do by ID, and then they have to basically perform an action on that to-do. They have to mutate that to-do, right? And so in order to not repeat ourselves, what we'll actually do is write ourselves a kind of a function that we can use for both cases. So basically, this function will take a mutable to-do. It will take a mutable self, right, which is the model, and then it will take the ID of the to-do, and then it will take an update function, and let's just call that F for now, right? And then in here it will basically find the to-do and then run that function on that to-do that it finds, right? Note that I'm not putting an export here, right? We don't want this to be exported. This is just inside the Rust app. We don't need that in Dart. But what I need to do now, I need to tell Rust in this case, what is the type of this function. And basically this function will take a mutable to-do, and it basically returns nothing. Okay, So now what we can do is we can say, and now this is why I love Rust and why I actually want to implement my logic in Rust, is because we can do things like this. We can say, well, give me all the to-dos, get the iterator for that, right? And we can also do that in Dart. I'm not saying that it's impossible. It's just really nice here. Then find this, right? Find this to do, and basically when the ID matches the ID that's given to me, right? And so basically now we have this. So there are two outcomes. One is that it finds it, which is basically to do, and none is that it didn't find it, in which case we need to warn something went wrong here, right? Could not find to do, and then we give it the ID, right? Okay, and then here what we'll do instead, we'll run the update function on that to do, and that's why we needed itermute here, because this update function takes the mutable to do, right? So that's what we can do. And now what we can do here is we should say update, right? Actually self.update to do, and we can say here's the ID, and the update function is, if you find the to do, right, completed the completed equals true, right? And this is very similar, so I'm just going to copy it. The only difference is that it's the opposite of what it's currently, right? So it's not to do completed, and that's it. That's all we need to do. By the way, for whoever just joined, I'm going to go put project here. This is what we're building. We're starting with the Rust version, the Dart only version, to make things a little easier and easier to understand. And then we're basically ending up building this up that I have over here. All right. So, okay. And again, any questions, any comments, let me know. This is why I'm doing this on Twitch, because I want to get some feedback. I want to help people out, and so on. If they have any questions. So. So we got all this set up. Now we can basically build this. And we can see now that we got more messages here. Complete to do, toggle to do. So this is a really good question. So there are ways to basically handle panics and make sure that they don't happen. Obviously, you don't want your app to crash on your phone, right? So basically, there are ways to properly handle those, and I'm looking into all kind of ways how to do that. But currently, RIT does not. It basically is very safe, because whenever you get a pointer, it makes sure that it's not null and all these things. So it makes tries as much as possible that you don't panic in the first place, right? So basically, the code that I wrote, the glue code, is very safe. Even though it's unsafe technically, but I really make sure to check everything, and also if something does go wrong, to give you really good feedback of what happened. But to just prevent panics altogether, or to basically be able to handle them in Dart, that's not implemented. But obviously that is something that has to happen. So I'm planning to do so. Good question, very good question. Okay. Where were we? Okay, what's next? So we now have these extra messages, right, that we can send. And now we can basically go back to our main file, and we can say, well, why don't you go ahead and model.message, and we're going to say complete the to-do, the first one. So, well, how do we get the first one? Well, we can say model.todos, and we can get the first one, right? So let me think about this. Well, we need the ID, right? All right. And then we can, so we then print it, and then we can, actually, let's do this. What we'll do is we'll print just that to do, right? Because we don't want to just print all of them here. So let's go ahead and print that. Let's see. So, all right. And it says debug true, and it says there's nothing like that there. Okay, no problem, right? Because we can just implement that here. So what we're missing here is a RIT debug, right? with debug, and now we just rebuild to get these extra methods created. And now, let's see, we should actually be fine. All right, so now it's no longer complaining. And what else? So I want to print that, and then basically what I'll do is I'll toggle it, right? And then we basically can see that it works. So we can toggle it and do that. And so now, if we run this, we have right. We have all the deals, and we have this first one. It got completed, and then it got uncompleted because we toggled it. All right. So that is how that works. But now we probably want to say, well, if you have a UI, right? Obviously, we want to. Let me actually separate this a little bit to make this a little clearer. So we're basically just setting everything up, and we probably don't want to even have to do this anymore. And here we basically complete the do and just play around with it a little bit. But what we actually want to do is in the UI, as we can see here, right? I'm gonna complete some, and then I want to only see the one that I completed, right? And if I uncomplete, then it just disappears from the view because it's filtered, right? And then if I look at the ones that are uncompleted, then I see that, and then here I see all of them, but right. So we need these filters. We need to say, well, show all, show the completed ones, show the non-completed, right? So we want to kind of be able to do that. Well, what we need to do obviously is implement something here that gives us only the completed to-dos, right? And so that is there's a lot here that we have to do. One is we have to add a filter. So first of all, let's implement the filter. So I'm going to implement a filter, and it's going to be completed, pending, and all, right? So either one of those will show. Okay. So now, well, Grid still doesn't know about this filter. We can actually prove ourselves that it doesn't, because if we re-render, there's nothing about filter here. Actually, Pfi Gen complains that the filter is here, but we didn't even put a wrapper C on it, so it doesn't even know what to do with this, right? Just a note about these other warnings, we don't care, right? Because we want to send these structs, we want to send them as pointers. So just real quick, so these the bind gen, sorry, the FFI gen, what it actually does, it will generate classes. Like if you have structs in C or in Rust, it will actually generate classes for you. But what happens if you do that? Well, let's say we had a to-do. I'm just going to digress real quick. If you have a description here, and that's like a really, really large string, right? Now, we want to do, and maybe we only want to show the title, like, because right here we don't want to we don't need the descriptions yet of these to-dos. Now what would happen though is we basically instantiate a class in Dart which would require it to also get the description. Otherwise, how is it supposed to instantiate properly if it doesn't even have the string yet, right? So what we do instead, we actually don't send a struct. We send a pointer to the struct, and then every time we access a property on this, like let's say on the on this here, right? If you say to-dos, I can actually access. Here you access the ID. Here's a good example, right? Once we access that, it actually then calls a method and then gets it from out of the memory, right? It doesn't instantiate it into Rust, or sorry, into Dart before that. So and this is needed in order to make sure that we have good performance, because we don't want to send across the boundary anything that we don't even need yet, right? I hope that makes sense. And if there are any questions about that, please do so. This is a little bit tricky to understand, especially if you're not like that aware of how basically FFI works and how the memory is basically shared across these different languages. Okay, so now we can go ahead and implement that filter. So one thing we have to do, as we kind of saw, we have to say wrapper C on the filter, right? And that basically just lays it out in memory in a certain way so that in the Dart end we can use it like we expect. And the other thing we're going to have to do, and we're going to do this piece by piece actually, we're going to implement, in case we want to debug it, right? And we're going to need to actually implement debug because we're going to use, actually, let's let the compiler guide us, right? So we have a filter, not on to-do, but on the model. So we have a filter here. Okay. So first of all, it's now confused of what this is, right? Okay, so we can tell it it's an enum, right? So we have to tell it. Enums, one of them is a filter. Okay, now it's happy. But now it's complaining that, look, you implemented debug here, but this filter doesn't. Okay, so let's do that, right? Let's implement debug here. Okay, derive, let's actually do it like this. And then we can also derive the debug for with what we added. Okay, now it's still complaining. It's saying clone is not found. Well, why is it clone? What's going on there? Well, read is basically implementing a method for us that allows you to access that enum, right? To access the filter on the model. And the way it is sent is basically by value. Like it's basically sent like an integer kind of. But in order to do that, it needs to clone it, and this is no problem at all because it's really cheap. It's just right. It's just like a small int or something like that. So we can just tell it to derive clone, and then everything is happy. So now we have a filter on that model, and we just need to do the initial one and call all. And now the beauty of this is, right, I can now build this again, and without doing anything, right, and running it again, now we can see that it's also listing the filter here, right? And this is because Rust derives these things for us, right? And we can make use of it even from Dart. So, right, we don't have to, and I wouldn't recommend implement toString, right? Okay. So let's keep going. So now we need to basically set the filter, right? So we need to have a message that that allows us to do that, right? So basically the idea is obviously we can say, get me all the to-dos that match a filter, and I pass a filter in. But if you think about how UI works, we can see that here that actually we are setting one, right? This filter now is X, and then the view changes, right? So we're setting the filter, and then we're getting the to-dos that match that filter. So in this case, so that's how we're going to do it. And we're going to pass a filter. And then again, we're going to be guided by Rust compiler and telling us what we need to do. And then we have the filter, and it's actually really simple because all we have to do is set the model filter. Whoops, that's not what I wanted to do. Set the model filter to that, right? That's it. That's simple. Okay. Now, why is it complaining now? Okay, so. Did we name it differently? Oh, well, it's not set filter. It's well, actually this filter. Let's see. Okay, so the problem was that we didn't again tell what the filter was. You can say, well, we already did up here, right? But as I explained, these attributes kind of function in isolation, and so we need to also here tell it what that filter is. And then everything is happy again, right? And that's a little bit unfortunate, but you just have to remember that all this macro, this message macro sees is this part of code. And this is also, again, for performance reasons. If you were to just put a macro on the top of all your code, and now you basically have to parse all of it and go through all of it, that wouldn't be working as well. So we just have to repeat ourselves a little bit, but it's not a big deal. Okay, so now all this works. We can set the filter now. Okay, so let's run the build. Right, and we're going to get another message and set filter. We also got the debug methods to see the filter, and all that is working splendidly. So now we're going to go back here, and for now we'll just basically set the filter, right, just for fun. It doesn't do anything yet, but we can set it anyways. And so now what we're going to have to do is there's going to be something called a rich filter. And that's basically the Dart version of the filter we have. So any enum that you have, you just put rid in front of it, and then you can access it like this. And also, since I said it's being sent via an integer, at this point we still have to just say, give it actually the index of pending. In the future, I'm thinking of maybe like, allowing you to just have to do this. But for now, you have to do it this way. And then what we'll do, we'll just print the model again and see if that actually worked. So let's just run it. All right, and so we can see that the filter changed to pending. But obviously now we are still at a loss because we don't know how do we now get the filter to do's, right? So that's the next thing we have to implement. So let's go first to the Rust end, and let's implement that. The image, okay, because magic. That's a good question. Let me actually expand something for you and that will answer your question. Cargo expand, but that's a really good question. So if oops, yeah, okay, so we can't really. It's going to be a little tricky to find, but basically here's a filter and it's wrapper C, right? And I think the message was right before that. So if you look at the message, it also got wrapper C. So it did get wrapper C. Well, but we didn't put it there, right? Well, thing is that since rid knows that it has to be wrapper C, once we put an attribute like that on top of it, it does it for us, right? Really good question though. Thanks for making me clear up these things that are confusing. Okay, so now we're going to implement filter to-dos, right? So it's also going to be fairly simple. So to-dos, and we're just going to take ourself, and this time we don't have to Model, right? Because we're just going to read, and we're going to return a vector, and we're just going to turn a reference of the to-do, each to-do that matches the filter, right? So, and now again, the magic of Rust works really nice. So what we have to do is, first of all, we have to look at what filter we have. So again, we don't want to do match self dot filter, right? That's what we already know that's something we have to do, and so we can implement the match arms already. So we have 3 ways, and we're going to basically say we want to get a vec of the matching filters, right? And it's going to be a vec of this. And so then basically depending on what it is, right, we're going to return a different kind of vec. So here basically we can say self.todos dot iter, and so basically we're just doing that in order to create a new vector, right? So we can't return the to-dos as they are, because that's the, and actually we don't even need to assign it, we can just do it this way. We basically we can't just return the vector directly, because right, we own it, so we can't just like move it out, right? The model owns it, and the model has to keep it. So now self.todos, and then we just filter them, right? We iter, right? And then we filter, and then basically, in this case, if x dot pending, right? Oh, we don't have a pending, but we can say x dot not completed, right? And I'm getting a little, okay. So and then we just collect those, okay. And then let me just copy this. And then here we can say all the ones that actually are completed and return those. And now you can see, well, it's complaining that since it's also private, right, it's not even a public function, that it's not using this function at all, we're going to have to export it. So we already said that there are exports in this impl block, so we already took care of that. We exported, and now we get the same thing again, where it doesn't know what the to-do is. So we're going to do rid structs and to-do, and then everything should be happy. Okay, so now we can get the filter to-dos. And now one big thing to notice here is this is a vector that we are creating here in this method, and we are sending it out, right? So Rust has no notion of this vector anymore. And this becomes important in a moment. We basically have to keep these in mind, these cases where basically we are creating something and we're basically losing track of it from the Rust end. In this case here, for this vec, right, we're never really creating a new one. We just always provide access to one that the model holds, right? So it's different. But this one here, we are creating a new one and we're sending it out. And I'm going to show what we have to do in that case for that. So what we're actually going to do is I'm going to implement a status method, and I already have it. So I'm not going to write this up again. I'm just going to copy and paste this from the example. So it's complaining this method doesn't exist, and that's because we didn't build yet. So let's see. Oh, should actually go away. Okay, now it went away, right? And basically what I had to do, I had to go down here to make Vim notice that something changed. So here we're going to get the total to-dos basically from the to-do length right here. And we're just going to print the filter right? Just to show what the filter is. And we're not using the pretty one because we don't want it to take like too much space. And then we basically match to-dos. And as you can see, we can iterate over these matching to-dos. And now this is the important part, right? We need to dispose those. So anything that Rid knows has to be cleaned up, right? It will have a dispose method on it. So this is kind of the rule of thumb. Like if something has a dispose method on it, you need to make sure to dispose it. Like if I take the to-dos that I got from the model, these ones up here, right? If I take those, there's no dispose method on it. That's because we don't have to dispose them. So that's kind of the rule of thumb that you can follow. And so now if I instead of printing the model here, I'm just going to print status, and I just pass in the model. Then we should get a nice little output. So you can see here that we have 3 total to-dos. We have a pending filter, and all of them are pending, right? Because we toggled this one back, right? But what if I said, so what if I just complete this one, right? And then run this code again. Now we can see that we only got these matching to-dos because the filter was pending. We have a total of 3, but since we completed that one, it doesn't match the filter. And that is where I want to basically stop with the Dart example. At least almost. One thing that we're still missing is how do I remove a to-do, right? So I want to at least finish that. But basically what I'm going to do is I'm going to put this link here that has the full example. So if you're interested in seeing the full example, that is open sourced, right? I mentioned earlier that Rid itself is sponsorware, so I'm trying to get enough sponsors to be able to open source it. But all the examples are open source. So this is the full example, which basically, I also have it running here. It works like this, where you basically we already have some to-dos here, and we can basically say, well, complete the first one, right? Then, I don't know, change the filter to completed ones, and then change the filter back to all. So you can kind of play, it's kind of as an interactive kind of thing, right? Again, all the logic in Rust, just the UI part in Dart. So you can look at that to see the complete version. But what I still want to do is I want to in this one here I want to still update the Rust code to be able to remove a to-do. Okay, so we have add to-do, and remove to-do is actually almost similar. So we're going to put it here because it's related, right? And we're going to give it an ID. And again, right, the Rust compiler will help us to know that we're missing something. And so, so we're going to put that here, and we're going to take the ID of the to-do, right? And so what we actually have to do now is we have to find the index of the to-do we want to remove, right? And then we remove it at that index. So let's first get that index, right? How do we do that? Well, index equals and match self.todos, and we want to get an iterator. We don't need a mutable one because we're not going to mutate the to-dos, but we actually need the index, so we're going to enumerate them, and then we find the one that has the. So we don't even care about the to-do itself. We just care about the index here. We just care about the to-do, and then we want to make sure that the ID equals the ID. All right, so that's how we find it, right? And let me complete the match arms. And so now if we find it, so we're going to get something that has an index and the to-do. And about the to-do, we don't care. So let me just highlight this so we get a reference to the to-do, but we also get the index. And that's basically what we want to return. So that's what we're trying to pull out. And then when we don't find it, we actually need to bail out here, and we're going to return. If I don't return, actually let me do it just to demonstrate why I need this. So, but we're going to do could not find to do, and it's kind of the same thing, right? Like we did before, and with the ID. And now if I do it this way, Rust will complain that, well, first of all, that I don't have the quotes. And now it will basically complain that the return type is different because this is an integer and this one returns void. right? We can't assign void to an index. And actually, you know, if we see that, actually, we need to get out of here. We need to we can't handle that message in that case, right? So let's just get out of here. And again, you can see that Rust kind of protected us from making a mistake here, right? Because otherwise, we would have like assigned void to an index or something like that, and I don't know what would have happened. And now we can basically say self.todos.remove the index. There's another one, another method in here in Rust that says self.todos.swap remove, and that's actually more efficient, but that reorders the to-dos, which actually we don't want. So we'll live with a little more performance overhead and do it that way. So now let's just build. And you can see we're starting to get a lot of methods. And you can think of all these things, all these methods you would normally, so even if you use all the FFI libraries that are available right now, aside from RID, you would still have to write all that boilerplate. So let me actually just demonstrate to you how much that is. So we got 92 lines here, right? Now if I expand all this, and then just count the, well, if I just count the lines, right? We're getting about 800 lines. And of course, there's also the clone and the debug and all these things. But a lot of that is what RID generates for you. All this boilerplate, you don't have to. And it's also much easier and less error prone, right? Because I make sure to get it right one time and test it and fix it. And then you don't have to do this for each of your models or whichever. Okay, so now what we can do, just for fun, we're going to remove one, model.message, remove to do, and let's just say we're going to remove the second one. One dot, oh well, sorry, to do's one ID. We're going to pass that ID. All right, and then we're going to print the status again. And actually at that point, and let's actually set the filter back to all, so we can see that it's actually gone. All right, so let's run it. And we can see, so first we had the matching to-dos, which were pending, which were these two. And now we set the filter back to all, and we only have two to-dos left, and it's these two. All right, so that's the introduction using the Dart, just Dart by itself. And to help, this was pretty understandable. If you have any questions, you can also go to the site. Well, that didn't work. Maybe I named it this. Okay, yeah. So this is where the RID website is, and where all these things that I explained here in detail are kind of explained. I'm going to still work on the documentation. In about so we reached this point. Actually, let me answer this question first. So if you tell RID what this URL is, right? That it is a struct, it will basically pass it as a pointer, but it will not necessarily generate the accessor methods, right? So basically, you can see that if I do a model here, let me actually open this, right? This is needed in order to generate accessor methods for these properties, right? So what you might have to do then instead is to wrap, to create another struct that basically wraps the URL from the URL crate, right? Because we cannot add attributes to something from other libraries, right, that we don't have access to. We can implement things for other libraries, but we cannot provide an attribute. So you could manually implement these FFI methods, and they would also work. But RID doesn't know. Yeah, it's a new typer, and you could call it, yes. So RID doesn't know. RID doesn't know how to do something for just types that you don't annotate. Let's just put it that way. Because what it basically does, it parses these fields, right, and it looks at what the types are and so on, and then it generates the appropriate methods. So you'd probably could some sort of like a decorator pattern where you're exposing all these fields, and when you create it, you pass in a URL from the URL crate, and then you get your own URL type. I hope that makes sense, right?